So, namaskar to all. Hello, everyone. I, Dr. Ribhu Abhushan Panda, again welcome you to my channel. This is the second video about the antenna design in HFSS. Basically, I am doing the microstrip patch antenna design using HFSS. If anyone has not seen my first video in where I have designed this particular microstrip patch antenna, this antenna I have designed in my first video. If anyone has not seen, I will give the link in the description. I will also provide my email ID, and if anyone wants to contact with me, they can contact with me through my email ID. So this is basically the microstrip patch antenna which I have designed, and step by step approach uh, is there in my previous video, which is the first video of this particular microstrip patch antenna design in HFSS series. So today we'll discuss about the parametric optimization, or in general language you can tell that if we change the value of a particular parameter, how the results will change. Means the change of result in accordance to the change of the values of a particular parameter or more than one parameters. That's basically the optimization in accordance to the parameters. So in the microstrip patch antenna, the length and the width, the feed width, this cut length, and the width of the ground plane, the length of the ground plane, height of the substrate, all these are one parameters. So you can optimize all these parameters, but it will take very long time. So today we'll focus on the parameter length and the width. So to optimize any parameter or to give any parametric setup, first we have to define a variable. So let me show you. For defining a variable, we have to use this particular symbol, dollar symbol, in the HFSS software. For an example, suppose I want to define a variable L for length, then I can write dollar symbol first, then I can write L. Similarly for width, dollar symbol first, then width. Then we can add, then we can optimize it. Okay. Then we can add it in the variable list and we can optimize it. So this is basically the process which we have to follow. So dollar symbol is used in the HFSS to define any variable. So let us see what I have done. So here I I want to optimize length and width of the patch, and the changes in the result any particular result you can take into consideration. For an example, S parameter or VSWR. So let us consider the S parameter will be visible. So this if I want to change optimize the length and width of this patch, and so that the changes in the result will be visible. So which result we are taking into consideration? As parameter result we are taking into consideration. So this is the two parameters which I am considering. You can consider any kind of parameters. Okay. So basically length and the width I will consider. Okay. So let us define two variables, dollar symbol L and dollar symbol W. So how you can do? See, already I have designed this patch. If anyone has not seen that video, I will give the link in the description box. You can go there and you can see the video. Now if you expand this page, there will be a thing that is create box. So if you click that, previously the values were there. Okay, so let me show you previously how it was there. So this is the previous design. So if I expand this page, see here you can see the values were there previously the values were there. Okay, so exact value uh, have been given. So these are the exact value based upon the calculation followed by through the specific formula. So these are the exact values. Now if I want to optimize, then what I can do, I have to define the variable. Okay, so here you can see I have defined the variable $L, $W, dollar symbol L, dollar symbol W. So L variable, W variable for length and width. So as the position started from length by 2, so instead of exact value, I have given this particular variable. So here also I have given this particular value. Evaluated values you can see here also. Okay, so I have done that. And what I can do next is that I will expand this design. So here you can see you can expand this design and you can go to the optimetric. Okay, you can go to the optimetric. So in the optimetric you can click and right click add parametric. Okay, you can click right click add parametric. So if you add parametric, it will ask different values of the different variables. Then you can click on that variable and you can give a particular range, or you can tell particular values, the minimum value to the maximum value with a step size. So I have already given. So here you can see parametric setup. So here I can see, you can see, I think it is properly visible. So here you can see I have given the variable the value for the variable L, that is 28.8 mm to 29.2 mm with a step size of 0.1 mm. Similarly, I have given the values of the variable for the variable W, that is 38 mm to 38.3 mm. You may ask why you have given this particular range. Because to make the simulation in proper time, in a short span of time, you can give a large range of values, no problem, but it will take more and more time. Okay, so if you take a large number of values, then the simulation will take more time. So to demonstrate what exactly is this optimization and parametric setup, I have given just a small range. So 28.8 mm to 29.2 mm, the step size is 0.1 mm. And similarly for the W, 38 mm to 38.3 mm, the step size is 0.1 mm. Then you can add this parametric setup, and then the same procedure, HFSS, you go to the HFSS validation check and then analyze all. If the validation check everything is okay, then only you can analyze that. So here you can see total it will take all the values into consideration and it will count how many times the simulation should be taken into consideration. So it is, I think, 19 times all the permutation combinations values have been taken into consideration, and it is 19 times, I think. So 12 already solved, means simulation is over for 12 values, and now it is solving one and remaining is 7. So around 20 or 19, that type of number of simulations will be taken into consideration. Now the main part is how the change in the result will come. So if you expand this result part and if you click on this S parameter, you can see not only one S parameter, different S parameter. Previously it was only one S parameter, but now number of plots will be there. Okay, so let me see. So you can go to the HFSS, you can go to the result. So model solution data report, rectangular plot, S parameter, that is dB, and you can click on the new report. So if you click on the new report, you can see number of plots are there. You can see number of plots are there, and here you can see for different values, different plots have been implemented. And see here you can see 28.8, W is 38. So here you can see number of plots are there. Now from these plots you have to determine which is exactly which is the most desirable plot, and corresponding values you can take into consideration. What, where, for what values we are getting our desired result, that is the objective. So here you can see, if I move the cursor, you can see here the values are changing. So if I move the cursor here, you can see this is 2.4046. So this plot is having the resonant frequency exactly at 2.4 gigahertz. So in this plot there will be a value for the length and there will be a value for the width. So if I click on this plot, so here you can see the length is 28.9 mm and the width is 38.3 mm. So this is the most desirable plot. So these values should be taken into consideration. So I can add a marker also here. So right click, add marker. So here I have added a marker. So the uh, resonant frequency is 2.4 gigahertz, and the S11 or the reflection coefficient or the return loss, you can tell that is minus 24.2315 dB. So till now all the values means whatever values we have given, the range of values, those were not taken into consideration. Some of them are solved, 13 are solved and 6 are remaining. So there may be different plots. Okay, it may happen that another plot will come which will be exactly resonating at 2.400, like that. It may also be some plots which will be deviated. So different type of plots you will get. So in this manner you can optimize any parameter of this microstrip patch antenna. So this is basically the parametric setup. Okay, so you have to see the first video, the detailed explanation of the design of the microstrip patch antenna for 2.4 gigahertz application. You have to see the first video, then only you can proceed for this next video. The link of this first video I will give in the description box. So I hope you have understood the parametric setup and the optimization of the parameters of this patch antenna. You can follow these steps and do the design. If you like my channel, if you like this video, then you can subscribe to my channel, and you can share this video to your friends who are interested in antenna design and HFSS software. Thank you once again. Thank you all.